We are learning about adding and subtracting rational expressions with common denominators and least common denominator. I know I've got this when I can add and subtract rational expressions with the same denominator, find the least common denominator of a list of rational expressions, and write a rational expression as an equivalent expression whose denominator is given. So the vocabulary today is least common denominator, or LCD, and equivalent expressions. When you add and subtract rational expressions with common denominators, you only add and subtract the numerators. So you can see, it says to add or subtract rational expressions, add or subtract numerators and place the sum or difference over the common denominator. So you're keeping the denominator the same. You're only adding the numerators or subtracting the numerators. One A. All right, a plus 3a all over 6. You could actually rewrite this if you want to, because it does have the same denominator, so it'd just be 4a over 6. Now we do have to simplify that, so the 4 and the 6 can both be divided by 2, so your final answer would be 2a over 3. And b, same denominator, so just combine the numerators. And then you see x squared minus 36 is a difference of squares that can be written x plus 6 times x minus 6. And then you can cross out the x plus 6, so your final answer would just be x minus 6. One B says subtract, so same denominator. So we're just going to subtract the 8y minus the 16. Now you should see that you can take out the 8 and be left with y minus 2 in the numerator, and then you'd have y minus 2 in the denominator, so you can cancel out the y minus 2's and you just have the 8. So you try this one. You should have gotten 7p plus 5 over 2p plus 7. Here's another one. Go ahead and try that. And you should have gotten 3 over y plus 5. To add or subtract rational expressions with unlike denominators, first you have to write the rational expression as an equivalent rational expression with common denominators. So the least common denominator is the easiest common denominator to work with. We are going to be adding and subtracting rational expressions with unlike numbers in the next section, but first you have to figure out how to get that least common denominator. So to find it, you're going to factor each denominator completely. The least common denominator is the product of all unique factors found in step 1 raised to a power equal to the greatest number of times the factor appears in any one factored denominator. And I know that sounds confusing, so let's try some. All right, so we are going to factor the denominators. So we have 6y in this one, and that I can pull out a 4, and I'm left with y plus 3. Okay, so out of 6 and 4, the least common multiple of those is 12, right? Because 6 times 2 is 12, 4 times 3 is 12. That's the smallest number that they both go into. Then once you're done with that, you can kind of like put a little check mark on it saying that you're done. And then you have y and y plus 3, so you have to write both of them. And that would be your least common denominator. Next, we're going to find the least common denominator of these. So again, I'm going to factor each denominator. So I get 5. I can take a 5 out and I'd be left with x squared minus 1, which is the difference of squares, so we can factor it again. Okay, so that's the first one. The second one is x squared minus 2x plus 1. And I can factor that x minus 1 times x minus 1, because that would add together to give me a negative 2x and multiply together to give me a positive 1. So what is the least common denominator? Well, I have the x plus 1's in common, right? But I only have one of them in common. So in that slide we saw a second ago, it says, see which one you have in common and then pick the highest of that. So we do not have a 5 in common, so I have to write it. We don't have an x plus 1 in common, so I have to just write that. Now I have one x minus 1 here and two x minus 1s there, so I have to write both of them. I don't write all three, I just choose the highest of those two. All right, you try this one. Go ahead and pause it. And you should have gotten x plus 3 times x plus 1 times x plus 7. And those could be written in any order. So we factored, and then they both have an x plus 3 in common, so I just write it once, and then I write everything else. Number 3 has some extra practice, but I actually want to do one with you before you start. So let's see if I can do this. All right, let's look at the bottom. Okay, so it says rewrite each rational expression as an equivalent rational expression with the given denominator. So let's look at A. What are they doing to 8m to get 72m? They're multiplying by 9, right? So I just multiply the 3 by 9 and I get 27. So what are they doing to x plus 4 to get 5x plus 20? Well, if I factored that, I would see that all they're doing is multiplying by a 5. So I can multiply this by a 5 and I would get 5 times x. So what you have to do is you have to factor these denominators and see what you need to multiply to the first to get the second, and then do the same thing with the numerator. Okay, so go ahead and pause it. And then these are your answers. So please let me know if you are having any trouble. So I know I've got this when I can add and subtract rational expressions with the same denominator, find the least common denominator of a list of rational expressions, and write a rational expression as an equivalent expression whose denominator is given. Do you really understand? Describe how to subtract two rational expressions that have common denominators. Then illustrate your description by subtracting x plus 2 over x squared minus 4 from 2x over x squared minus 4. So describe how to do it. So you're going to subtract the numerators and write the difference over the common denominator. Then you would need to factor the denominator and the numerator if possible and divide out any common factors. And you should have gotten 1 over x plus 2.